Hey everybody, this is Dark Guardsman. We're back with another video. Now yes, we've got another video including the visualization software. For those who haven't caught on now, this is now going to become the new standard. I end up doing everything development-wise. Anytime we ever have a question where we want to know what is the data doing, what does it look like, and are we right about the assumption of the data, I'm going to be building a visualization piece of software in order to allow me to summarize the data in an effective way where it's not too bad to deal with and is very easy to render. Or deal with is the way I meant to say instead of render. Now, for those who've been keeping along, we now have multiple new tabs. I've already showed off the path tab, which allows you to calculate the path of a missile, the accuracy tab, which allows you to calculate the accuracy, and the spawning tab, which allows you to calculate or kind of look at how spawning works. Not a perfect thing, we're going to definitely work on that more. But the three new tabs we've added is a tab to look at the Redmatter render. Now this doesn't actually look at the render code itself, it looks at some variables in it, a sine and cosine visualization, and a sine wave generator. So the actual Redmatter render, which let me go ahead and full screen this, is just a very simple data set that allows me to look at the variables that are going on. The red right here is the amount of ticks we use for the rendering. It'll go up to a value of 200, drop back down, go up, back down, and stuff like that. This is the reason why we have a very jarring-like motion with our animation. I'm not even sure if it's intentional or not. The green is the number of beams rendering. This will go from 0 to 61 as it goes, so this is about value 61 right here. I know there's no ledger when it comes to the edges of this to really figure out what the data is, but I actually know what the data looks like, as I can literally open this up and I can look at the data down here. Now, one of the collars down here is a time scale and the other one is a size scale. I have figured out, thanks to this piece of software, that the size scale is responsible for the beams getting larger as time goes. So for those who've actually seen the ICBM render, and for those who haven't, let's go ahead and look at it real quick to compare. So we'll open this up real quick. This world should already have a Redmatter in it from yesterday when I was showing off the new feature I was implementing when I was being bored waiting for a team meeting to start for class. I actually figured out during that team meeting that a lot of interesting things. Yeah, that shouldn't be happening. But as you can tell, the thing kind of has a tendency to scale out and do stuff. I think we're having some race conditions problem here right now. The reason why it's going so fast is a little hard to look at. But effectively what happens is it goes to a 0 point, it starts generating beams, and then goes back out and then back in. And let me actually pause this real quick and look at the code to see what in the world I did to break this. Doesn't look like I've changed anything. Yeah, we are definitely clearly seeing a acceleration of this. I'll definitely have to work on this more, but it's got a randomization going on, it puts things out. Of course, I changed the color of this just to screw around yesterday. But what you'll see is the beams will get larger until they basically take up your full screen, and that is the actual size scale variable. We've got a size scale variable right here. And how this effectively works is that as we're getting near the end, for the last 50 ticks of the cycle, it will grow the beams in size. So as soon as the time scale gets over 0.8, we then set the size scale to a value that's pretty much the time scale minus 0.8 divided by 2. And this directly influences the beam width and length down here, and actually will increase those by a factor of 10 for the length and a factor of 2 this. I'm very likely just going to remove this code right here for these pieces because I don't really want the growth, but I'm going to look at it and actually take time to mess with it and figure out what's going on with all the details and everything else. So that's one of the reasons for the visualization software is we can sit here and we can look at what this variable does. So these two variables down here, one is our time scale and one is our actual thing. And we can actually look at these. I've actually added some options down here to actually turn off certain things. So we can hit calculate and look at these. So I believe if I remember how the code works, and let's just go ahead and confirm this rather than me just sitting here guessing. And yeah, panel Redmatter render. And if we scroll down, we should see the plot. So yellow is our time scale, and then blue is our actual size scale. So if we pop back to this, we can look at this, and we can pretty much see what exactly is going on. As our time scale goes up, right around when it hits about 0.8 here, this is when the actual size scale starts to go up, and then it immediately drops back to 0, and this is the jarring motion I was talking about in the animation. This is exactly what the data is showing us, is that we're getting this jarring motion back and forth. And this is definitely something I want to fix and make it so that way you don't get this where it just goes up, and all suddenly drops back down to 0. I don't want that because that is what we call a jarring animation. It just looks bad, feels bad, ignoring the fact that for some reason the render is going like Mach 15, and I still don't understand what that's going on. However, looking at OBS on my left screen here, I can see OBS is skipping frames continuously. So I'm going to say it has something to do with OBS attaching to Minecraft and has screwed something up with the render code or some bizarre thing like that. I don't have definitive proof to say that's what's going on, but I'm going to guess and say that actually is related in some particular way. More than likely, it's probably just I messed the code up some way. But we can look at all this stuff, and to fix this, in order to get the jarring motion to go away, what we need to do is create a curve. And what I mean by a curve is, let's pull up Paint here. So right now, this is pretty much what our animation looks like. We go up, we go down, we go up, and then we go down. So we got a sawtooth waveform. What we actually want to have happen is to have something like this happen, where then it goes up, we'll cycle through and come back up, which is basically a sine wave, or you could use a cosine wave if you really want to. One is just literally shifted from the other. So we want to replace our sawtooth with a actual waveform, and that's the reason why we got the other two tabs. So now I can sit here and I can stare at what a sine and cosine wave look like. I can sit here and tell how many runs I want to look at. So say I want to only look at 2 runs. And say I don't want to really have 360 segmentations. So this is right now we're doing 360 segmentations, which is the number of degrees you have. And say we're only going to be updating this 200 times, which is right now, if you look at our code for the actual render, we effectively update every 200 ticks for this animation. If we go back to this, we set up the segmentations, and I can sit here and look at what does 200 segmentations look like for a circle type path. And it'll actually sit here and show me, and if say I want to change the animation to 20, it'll now show me what the data points will look like, where I'll actually be at, but it still tells me that if I use a sine or cosine, I still get that nice smooth motion back and forth. And for those of you who will be looking at this like this doesn't really look like a proper one, that's because the amplitude on this is kind of modulated by the scaling of the GUI. But this is actually one full cycle. This is actually 2 pi is what it is, which is what a sine wave actually is. Now, to add to this, I made a sine wave generator so I can actually look at the data. Now, you're going to look at this and you're not going to be able to see what's kind of going on just because there's not a lot of data points going on here. But what this is designed to do is I can figure out, okay, how much time do I want to spend looking at the graph? So say I want to look at 1,000 time unit. And then what is my frequency of my rotation? Say I want to do 100. I can then look at the amplitude. The amplitude actually controls the height of this. So say I want an amplitude of 2. And then we can also mess with the phase shift and the bias, which we're not going to mess with. And we can sit here and we can look at this. So we can actually see, okay, what happens. Now, let's say I want to actually do mess with the phase shift and I want to phase shift it by 90 degrees. I can actually watch that shift by 90 degrees. Now, say I want to bias it by, say, 20. I can actually see that that will scale all the way up. And what bias actually literally does is it just moves that waveform up and down, which we really don't care about because it's not going to affect our render. So that'll be set to 0. But now I can sit here and look at this data and I can figure out what equation do I want to use in order to make this actually do what I want it to do, which right now is just amazingly bad to look at. And I apologize for those who have to look at that and probably get sick from it. So, yeah. New tools we now have to toy with stuff, and the goal will be to change pretty much this section of the code to figure out some kind of way we can make a nice, smooth, beautiful animation. And more than likely what's going to happen is it's really just going to be this variable. It's going to change a lot, because right now this while loop is pretty much anytime this goes to 200. So say this goes exactly to 200 to 1, it'll drop it back to 100 to 1, which is pretty bad. It's not exactly what we want to have happen. So we'll have to definitely fix that. And then the next thing we'll probably fix is this right here. This is what's probably going to get plugged into the sine wave, is because this is our time scale. We're basically saying, okay, we know the number of ticks we exist for, and we know the number of ticks our animation should exist for. So now we want to figure out what is the waveform that we want to use, and this will probably just plug this directly in the side. So this will be our ratio, and we'll times this by 2 pi, and then we'll plug that into a sine function, and we'll actually get a return back that's a nice, beautiful waveform that we'll then plug in to the size scale if we actually do want to keep a modulation on the size, and then we'll plug that down into the rest of this pretty much down here, because the time scale also modifies the rotation of the beams. We have a nice little randomization going here. It's not a true random, it's kind of a fake random, because it uses its own random function that is more consistent, because if you didn't have a consistent function, what's supposed to happen with this, let's actually reboot this and see if rebooting it actually fixes it. If not, we're going to definitely have to look at the code and figure out what's up. Not as bad. Definitely something is still wrong. So let's actually go through here and figure out what in the world did I break. I don't see anything broken. That's the really sad part about this. Something is causing the core to accelerate on this and actually get us more tick rates. So let's actually stare away. Yeah, definitely getting a lot of stuff here. I'll figure this out later, but I'll come back here with another video talking about it, showing the improvements we're going to make, and showing a much better render that is not hard to stare at. And yeah.